Okay, so we're starting a new unit. This is Unit 8 on quadratic functions. Now, before we jump into the quadratics, let me just remind you that almost the entirety of the first semester was spent on linear equations. And as you'll remember, if this was a coordinate plane, linear equations have the parent function of y equals x. If I were to graph y equals x, it would be a straight line that goes through the origin where the slope is 1, positive 1 slope. And so that's our linear parent function, and you'll recall too that we use this format for our equations most of the time. Y equals mx plus b. M is the that's to the first power. That's why our lines come out straight. Okay? Quadratic functions are going to differ from linear functions, obviously, and this is how. So let's turn the page on your yellow booklets to page 1 of quadratic functions. And we want to write the quadratic parent function here, and that equation is y equals x squared. So when we have a function where the highest power in the function is a squared term, then it's going to be quadratic. Now this is the parent function. It's the function where all other quadratic equations are derived from this one. This is the mama function, so to speak. Okay, so I'd like you to hit pause on your video, and we picked out some points on the table, and I would like you to put these numbers into the equation y equals x squared and figure out what y is. Remembering that we always want to use parentheses when we substitute. Okay, so find those values and go ahead and graph them on the graph to the right. So take a moment and do that. Okay, so hopefully your graph looks a little bit like this. Now, because we used parentheses on all of these, our negatives became positive. A negative 3 squared. Negative times a negative is a positive. So you should have 9, 4, 1, 0, 1, 4, 9. And you can kind of notice just from the numbers that our graph is going to go down from the left and then go back up. You can see that in the values there. So we started at 9. We kind of came down and we went back up like that. So that's our quadratic parent function. If you want to put that into your calculator just to see it look nice and pretty, you may. Now, let's look at the domain and range. Remember, domain, let's not forget old dolar. Domain goes from left to right. So you'll notice, even though we just picked out a few points on the parent function, we could have picked out points to infinity. And you'll notice that from left to right, we're going to infinity. So we're going to call that all real numbers. The range, on the other hand, remember the range, robot, the range goes from bottom to top. So let's look at the bottom of our graph. The bottom of our graph is down here, and the top of the graph, again, has arrows going to infinity. So we're going to write that as y, all the y values are greater than or equal to 0, because this is 0 down here. And everything on this graph is above the 0 point. Okay, so y is greater than or equal to 0. Now, the vertex is the point where the quadratic graph changes directions. So we went down, it's the very bottom point or the very top point of a quadratic equation. So in this case, the vertex is 0, 0. It's the point right down there on the bottom. And now the next question says, is it a minimum or a maximum? And you just have to be very intuitive about this. This point is at the very bottom, so that's the minimum point. The vertex is the very minimum on the graph. All of the other points on the graph are above it. Concavity refers to this open area inside, and it's asking, is the graph opening upwards or is it opening downwards? Well, no, it's not opening downwards, because if we went down, we get stopped at the bottom. So the concavity of this graph is up. or upwards. Then finally, we want to determine the line of symmetry. The line of symmetry is the line that cuts the quadratic graph into two identical sides. And on this graph, that's going to be like this, straight down like this. So we need to give that graph, that line, we need to figure out the equation of that line. Well, obviously it's a vertical line, so that's a Buck's line, which means the equation is going to be x equals something. Well, what does x equal in this graph all the way up and down? X equals 0. And in this case, where x equals 0 also happens to be the y-axis. So on the parent function, the y-axis is the line of symmetry. Now, I want you to note that the line of symmetry always goes through the vertex. And because it's an x equals line, and they're always going to be vertical, and here's our vertex over here, and since I know it goes through the vertex, this is x and this is y, it's always going to be the x value on the vertex. So if you get a question like that about what is the equation for the line of symmetry, and you know the vertex, it's going to be whatever x is on the vertex. Okay, so that's a brief overview of the quadratic parent function. Now we're going to go down and identify some parts of the quadratic graph. This is some good vocab for you. Okay, so let's first pick out some things that we know. The first thing is, we know this from the graph above when we did the parent function, that this point right here that has the little call-out box is the what? That's the vertex. And let's label the vertex with a coordinate pair. So it's at -1, -4. Secondly, let's look at this call-out box over here, and it's pointing to this line right here. I'm going to kind of show it in orange, and I'm going to use a dotted line like this. And that is our what? What is that line that splits the parabola in half? That is the line of symmetry, or you'll very often hear it called the axis of symmetry. The line of symmetry or the axis of symmetry, and it has an equation, and the equation is always going to be what? It's always going to be x equals something, and we know it goes through the vertex, so you can see it on the graph, x equals -1, or we can see it right here, x equals -1 on the vertex. Now, the other 2 points where the call-out buttons are showing are what we call the roots. So let's write the word roots in here. And that's this point where it crosses the x-axis and this point where it crosses the x-axis. So let's determine the value of those using a coordinate pair. The one on the left is -3, 0, and the one on the right is +1, 0. Now this is very important because you will see questions like this all the time. The roots, let's say it again, the roots are the points where the parabola, that's the shape of our graph, the parabola crosses the x-axis. Now here's what I want you to remember, that we have 4 different names for the roots. We call those the x-intercepts, course, we call it the roots, which we just talked about. We call those the zeros and the solutions. So all four terms can be used interchangeably, and on STAR tests as well as quizzes and unit tests, we could ask you using any one of those words, and we still mean these 2 points, the points that cross the x-axis on the parabola. Okay, so there's your vocab on the parabolas. Now let's go to page 2 and identify some things on some graphs. Okay, so we have 3 graphs up here at the top of page 2, and I would like you to quickly hit pause and identify the vertex and the line of symmetry on all 3 graphs. So I'm going to hit pause as well. You do it, and then we'll check our work. Then we'll discuss what's on the bottom. Okay, so I hope you have -2, 2, 2, 4, and 1, -4 for the 3 vertices on these parabolas. And then the line of symmetry is the vertical line that splits them in half. And remember, the line of symmetry is always going to match the x value on your vertex. So you should have x equals -2, x equals 2, and x equals 1. Now, on the next line, it says this is the function that created these graphs. And you'll notice these functions are in the format of the functions that we have been factoring and doing in units 6 and 7. They are all in the format of y equals ax squared plus bx plus c, the standard form of a quadratic equation. So we already have been learning about a, b, and c in our previous units. So I want you to ignore the one with the fraction because we're going to change that in a minute. But why don't you go and write the values of a and b across there? You should be able to do that very quickly. Now, here's what I would like you to do in the bottom square. I would like you to write this formula, and the formula is the opposite of b, -b, over 2 times a. -b over 2 times a, this happens to be the formula for the line of symmetry. So we're going to write that again down here on this vocab line. The line of symmetry, x is equal to the opposite of b over 2a. Now, if we did not have these graphs up here, just up above, we looked at the graph, we could see the vertex, and we knew what the line of symmetry was based on the vertex. But what if I didn't have the graph? What if all I had was the equation? Well, since we have this formula, we can take the opposite of b over 2a, and we'll get the formula. So let's look at the first one. We have x equals, and the opposite of b on this one, we had -8, is now +8, over 2 times -2, which means 8 over -4, and 8 divided by -4 is -2. And you'll notice that matches the line of symmetry that we figured out using the graph. Okay, so let's try it again. On the next one, we have x equals, and we're going to do the opposite of b, so we're going to make it -4 over 2 times -1. So that's going to equal -4 over -2, and a negative divided by a negative is a positive, and so we get x equals 2, and again, matches what we saw in our graph. So the last one, of course, is going to be the same. X is equal to the opposite of b over 2 times a, so we get 2 over 2, and that equals 1. So if you're given a quadratic graph and you're asked about the line of symmetry, you can use this formula to determine the line of symmetry, even if you don't have the graph available. Okay, so we're going to try that on the bottom. Okay, so it says find the axis of symmetry for each of the following parabolas. Well, look, all we got was an equation, no graph. So what we want to figure out is what is the value of A and what is the value of B. So the value of A in this one is -2, and the value of B is 1/3. So how are we going to get the equation? This one's a little challenging. No kidding, starting off with an ugly F word, fraction. So we're going to do the opposite of B, so that's -1/3, and we're going to divide that by 2A, so 2 times -2. So let's, I'm going to write it this way. That means -1/3 divided by -4. And I'm going to put a 1 under that 4 because we can do that without changing it. Now remember, when we divide fractions, we leave the first fraction. So I'm going to put an equal sign here. So we have -1/3. We leave the first fraction. We change the division to multiplication, and we flip the second fraction. And so we have -1/4. And so -1 times -1 is +1, and 3 times 4 is 12. So x equals 1/12. Okay, that one was kind of ugly. Now let's try the second one. The second one's not hard, but it does have a little wrinkle that we didn't talk about in. X squared minus 7, A is equal to what? What's the value of A is 1, and the value of B, well, I don't see an X term on here, so the value of B is 0. So we're going to do the opposite of B over A. Well, -0, that doesn't even make sense. 0 is neither negative nor positive, over 2 times 1, 2A. So you get 0 over 2, and that's 0. I will say this, if you put -0 divided by 2 in your calculator, it's still going to give you just 0 because there is no negative or positive with zeros. But your calculator knows that. Okay, now let's do number 3. The value of A is equal to 5. The value of B is equal to -20. So find your line of symmetry, or axis of symmetry. We're going to do the opposite of B, over 2 times A. So that's 20 divided by 10, which equals 2. So x equals 2. There's your axis of symmetry. Now, at the bottom it says write the following equation, quadratic equation, in standard form. So remember, standard form is ax squared plus bx plus c. So we want to have a, b, and c all on the same side. So what we're going to do is subtract, well, we could do it a couple ways. How about we leave the 3x squared, and it's positive, and add 5x. So I'm going to put 5x, so I get 3x squared plus 5x equals 4, and then finally let's subtract 4, and we get 3x squared plus 5x minus 4, and if everything is gone from one side or the other, we're going to put a 0 there, and we'll say y is 0. Okay? So there you are in standard form, ax squared plus bx plus c. I do believe that, generally speaking, standard form, they like the a term to be positive when at all possible. So there you go. I hope that helps you. And let's just flip to the next page. We're going to do 2 of these together real quick. Okay, so I would like you to refer to the first page that we did, page 1, and see if you can fill out these top 2 graphs. Hit pause, try it, and then check your work in a moment. Okay? Okay, so I said that, but on the second one, we hadn't really talked about these terms. This, when the point is the highest most term, guess what? That's a maximum. And since this, all the points are going down, the concavity is down. So I didn't give you an example of those before, but hopefully you were able to figure it out. The vertex on this one is negative 2, 6. The axis of symmetry or line of symmetry is x equals negative 2. See how it matches? The domain, we got arrows down here, all real numbers, and the range is going to be y is less than or equal to, this time, this top number, which is 6. And then here's your answers for the other one. Okay? We'll save the other two to do in class. Okay? And we're going to keep doing quadratic equations a lot going forward, so if you have any questions, please come to tutoring. Okay? See you in class. Bye.